Okay guys, so we were discussing relative motion in 1D and I have discussed some basic concepts with you. So let's, talk more about, the basic things and all. Okay, just 1 minute. And in fact, I give you a problem and then we'll discuss. So problem is like this. There's a, say for example, there is a car. I just draw a rough car. Okay. And it is moving. It is moving with, say for example, 30 meter per second. 30 meter per second. And acceleration, I can say that 2 meter per second square. 2 meter per second square. Okay. And now there is another cart, I must say. There is a cart. Okay. The velocity of the cart is like 10 meter per second. And acceleration is 4 meter per second square. Okay. And the distance between them is 100 meter. 100 meter. So if I need to find whether the car ever be able to catch the car can catch cart, or when. Second question is, if you really, then when. That means time. You need to find the time. Okay, so there are two questions. Okay, so let's try to solve it. So the easiest way, you can solve it with the long mathematics process, long physics process, but the easiest way is to solve it by relative. So what I do, I would just sit on this frame, on the frame of the cart. Okay, now I will solve everything from the frame of the cart. So the relative velocity of car, I can say this velocity of car, in fact I would represent by u of car with respect to the cart. So that would be car minus that of cart. So that is 20 meter per second. So it would look like 20 meter per second to me. Okay, because I'm at the cart. Frame of reference is the cart. Okay, just give me a second. Okay, and then if I say the acceleration, let's come to the other page. Acceleration of car with respect to cart. So what was the acceleration of a car? It was 2. And what was of that cart? It was 4. So minus 4 is to minus 2 meter per second square. So on the frame of the cart, it would look like the car is moving with a velocity of 20 and acceleration of minus 2. So I'll just give you an idea how would it look like. Say this was the car. Okay, if I say, and this was a cart, if I say. So from the frame of the cart, it's looking to the car. Okay, so it would look like the car is moving. We are observing from the cart frame. The car is moving with a velocity of 20 meter per second, but acceleration is negative direction. It is negative 2 meter per second square. So whether it would be able to catch the cart or not. So it would be just the case of when it is going to stop. If the distance is less than 100 meters, so it's not going to stop it. Actually, it's from the cart frame, it would look like it is coming like this, and then it is getting stopped, and then it is moving back. Okay, it is moving back. So we need to find the maximum distance, positive displacement in the direction of the car traveled by the car. If that is less than 100, so it is not going to catch it. In fact, from the frame of the car, it looked like it is moving backward. So just I need to find the displacement of the car from the frame of the cart before it is getting zero, before the velocity is getting zero, before the velocity is getting zero. Okay, so this is the okay. So let's do it. So I just need to, acceleration is constant, so I just need to apply one thing, and that one thing is nothing but just the equation of motion. So which is v square u square plus 2as. So what is v square? It is 0 square. What is u square? 20 square. And what is acceleration? I think it is -2, and s I need to find. So s is coming as 100. So of course it is going to just catch it, 100 meter. Okay, it is going to just catch it. So if I ask you one thing, say, I just want you to think, okay, say that if the distance between them had been, if the distance between the two cart and car had been 50 meter, less than 100 meter, then if you're going to solve it now, so then you will get two answers, two time, because the maximum distance is going to travel before, you know, velocity getting zero or before turning back is 100 meter, but now it is 50 meter. So from the frame of the car, it would look like the car is coming and it crosses it, cart, and then it again turn back and then come. So there would be two answers. You solve it by this, there would be two answers. If you need to find the time, actually we need to find the time. First answer is correct, it's going to just catch, and second I need to find the time. So displacement I know, s is equivalent to ut plus half at square. Okay, or you can easily solve it by v is equal to u minus plus et. In this case, as we know it is going to catch it, and when it's going to catch it, when the velocity is getting zero. So velocity is getting zero, which time? U is 20, a is -2, and time I need to find. So it is u is 0, so it is nothing, 2 by 20 by 2, and this 10 seconds. But if you are going to apply for this, for the second part, the time would be 2. There would be 2 time. Okay, I would use f is equivalent to ut plus half at square. Then it is going to and t square. Can you see that this is quadratic? Then you get the time, and believe me, it would be 2 times. Okay, I just need to tell you, we are not solving it and not complicating with the maths. So now the second part, motion under gravity. The main topic which we are going to discuss is motion under gravity. Under gravity. So let's talk about this, motion under gravity. Now motion under gravity, in this topic we are going to talk of those concepts where only one force is present, only gravity, and only one acceleration is present, that is g, which is called acceleration due to gravity. So which is called acceleration due to gravity. So only this acceleration is present, and its value is 9.89 meter per second square, or we can also take 10 meter per second square. Now I know, because this acceleration is constant, okay, to some extent, to some height is not constant everywhere in the atmosphere, everywhere in the earth. So to some height, to some depth, it is constant. So we are going to take this value as a constant value, and when there is a constant acceleration, so what we have learned, we can use equation of motion. Okay, 3 equation of motion, and the fourth one is I'm going to tell you further, but 3 equation of motion we are going to use. Okay, so a number of problems can be made from them. So let's solve it. In fact, it is the right time to instead of pitching it's a different topic, different chapter, I took it like this. Okay, just a part of the best, you can take as a big question from those equation of motions. Okay, so let's take an example. And what is the example? Say for example, I took a case, there is a ball, you throw it with a velocity of 1000 meter per second. Okay, so what is the maximum height it would gain? Now you must be wondering what I asked, but it is the same like the equation of motion. I was saying it is just a big question of equation of motion, and equation of motion we had discussed so far. Say for example, you throw something, a ball with a velocity of u, okay, and I ask you maximum height attained by it. So how can you solve it? Maximum height would be there when it is going to stop, v equal to 0. So I can apply this thing, v square u square minus 2gs. So s would be u square by 2g, or s I can replace it with h max. Maximum height is u square by 2g. That's it. Okay. And if I need to find the time of flight, in the same case, if I need to find the time of flight, somebody asked me what is the time of flight if I throw it with a velocity of u, and it goes, the whole flight is like it goes to the up and it comes back. So what is the velocity at the topmost point? 0. So if I need to find the time of flight, okay, the total flight, now it comes again downwards. So what is the displacement in the total flight? 0. So I'm going to use this thing, displacement is 0. Okay, I need to find the time of flight, so I would apply this, ut plus half at is minus g, because g acts downwards, so I'm going to take it minus g. So s is 0, so eventually I can write this, g acts downwards, this. So time of flight is 2u by g, nothing. Okay, and maximum height is u square by 2g. So let's come to the problem I asked you. So I asked you a problem, and the problem was this one. Say for example, I throw a ball with a velocity of 100,000 meter per second. What would the maximum height achieved by it? So this is the case of motion under gravity. Okay, only gravity is involved. So h max, I'm going to use the formula u square by 2g. So u is 1000. 1000 square is like you need to multiply 1000 2 times, and 2 into 10. This is like 50, and this is like 50,000 meter, or you can say 50 kilometer. Now you would say this is the answer, and one of the answer choices must be like 50 kilometer for sure, but this is wrong. Why this is wrong? Because 50 kilometer is a big distance, and 50 kilometer from the surface of the earth, the g is going to change definitely. You can take just like the 10 kilometer or less than 10 kilometer, the limit where g is not changing. With 50 kilometer, g varies. The acceleration due to gravity varies. It's a considerable good height. It is a considerable height, and g varies. So this is not the answer. This is incorrect. In fact, we solve it by energy conservation, which we will learn further. I just need to show you the limitation of most of the kids. How does the most of the kids commit some mistakes? So that's why I discuss or disclose this thing to you. So we solve it by energy conservation. We apply the total energy at the surface equivalent to the energy at the highest point where it's escaping the, or not escaping, where the velocity is getting 0 or somewhat like that. Okay, maximum height is there where velocity is 0. Okay,